For a century, NASA has been our clearest window to the cosmos. So why are backyard astronomers suddenly beating them at their own game? They're capturing sharper details of Comet 3I Atlas, revealing features that official releases barely hint at. There's a sunward jet, a strange retrograde orbit, and image gaps no one can fully explain. Suddenly, a quiet visitor feels more remarkable than any major discovery. What exactly are we missing, and why? On a clear July night in Austria, Michael Jagger pointed his telescope toward the faint blur of 3I Atlas. Using a cooled camera and stacking 45 one-minute exposures, he captured a view that would send ripples across astronomy forums. The image showed a crisp bright nucleus, a structured coma, and a tail splitting cleanly from the core features strangely absent from NASA's official gallery. Jagger's method wasn't unique. Across the globe, a network of dedicated hobbyists followed similar routines. They aligned each frame on the comet's nucleus, stacked dozens, sometimes hundreds, of exposures, and used special filters to tease out faint jets and subtle boundaries. When these images were compared side by side with NASA's press releases, the difference was impossible to ignore. Where official images looked soft, the amateur composites revealed sharp contrasts and intricate structures. Contributors like François Caugnol in France and Damshu Kazaretti in India shared detailed notes on their process. Discard blurry frames, align on the nucleus, stretch the histogram, and use sharpening masks to highlight faint outflows. For many, the motivation was simple: curiosity, pride, and the thrill of seeing what the world's biggest space agency seemed to leave out. In one forum, an amateur joked, "If NASA won't show it, I guess it's up to us." The global community of amateur astronomers didn't just fill a gap. They became trusted witnesses, proving that with patience and the right tools, a backyard telescope could reveal what billion-dollar observatories sometimes miss. The sharpest window onto 3I Atlas wasn't in institutional archives, but in the hands of those willing to chase the comet through the night. The most debated feature in these amateur images is a forward-facing jet and arc of material blazing ahead of the comet, directly toward the sun. This isn't a camera trick. Over weeks, dozens of independent images from Chile to Austria have shown the same sunward fan. It's bright, persistent, and undeniably real. The puzzle deepens when you look at its orbit. 3I Atlas travels backward against the flow of the planets, yet its path hugs the ecliptic plane where most solar system bodies travel. Orbit modelers at NASA flag this combination as extremely rare. Internal comments from JPL even called the path one for the textbooks. The jet's orientation only adds to the questions. In most comets, jets shoot out from active regions, but they rarely anchor themselves sunward for weeks. The forward-facing jet on 3I Atlas suggests a patch of highly volatile ices newly exposed to sunlight. Some professionals argue this can happen on a comet's first approach, but its persistence keeps the debate alive. The combination of a steep retrograde orbit and a stable sunward jet hints at processes not captured by current models. Spreadsheets circulate with possible origins, but the numbers keep leading back to the same conclusion. 3I Atlas doesn't fit into any familiar category. As one planetary scientist put it, we are seeing something that feels both ordinary and statistically unlikely at the same time. This isn't the first time we've seen a comet defy expectations. See 2014 UN271, known as Bernardinelli-Bernstein, emerged from archival data as something entirely outside the norm. It was a comet of staggering proportions, roughly 150 kilometers across, dwarfing nearly every other known comet. But it wasn't just its size. Its activity began while it was still far beyond Saturn, where sunlight is faint and water ice is rock hard. In 2014, a faint coma appeared, an early sign that volatile material was escaping its surface. By 2021, with the comet still incredibly far out, radio telescopes detected carbon monoxide streaming away at a rate of billions of tons per year. The James Webb Space Telescope revealed a cocktail of supervolatile ices: carbon monoxide, carbon dioxide, and ammonia, each normally locked deep inside primordial bodies. The sheer rate of carbon monoxide production shattered records for cometary activity at such distances. These findings forced planetary scientists to reconsider what they thought they knew. Standard models predicted that only small, fresh comets might show brief outbursts so far out. Bernardinelli-Bernstein's persistent coma, sustained across years and vast distances, pointed to a huge untouched reservoir of ices preserved since the solar system's birth. Theories ranged from slow internal heating to cryovolcanism. One fact was certain: no comet had ever behaved like this. It had redrawn the map of cometary behavior, hinting at mysteries still hidden beyond Saturn. In just 8 years, our solar system has hosted 3 confirmed interstellar visitors. In 2017, Oumuamua slipped through with its strange tumbling shape, leaving astronomers arguing over what it even was. 2 years later, Borisov arrived, looking more like a classic comet but with a composition that raised new questions. Now 3I Atlas adds its own set of puzzles: a retrograde path, a persistent sunward jet, and a visual story that splits sharply between amateur and official images. This kind of clustering defies centuries of skywatching. Whole generations used to pass without a single confirmed interstellar object. Survey scientists point to powerful new automated sky searches like Pan-STARRS and the Zwicky Transient facility. Their wide-field cameras sweep the heavens every night, catching objects that would have gone unnoticed a decade ago. Some researchers argue that Earth's neighborhood may simply be denser with interstellar debris than we thought. But even among professionals, the timeline feels abrupt. Papers published just before this flurry began estimated that interstellar objects might be found once every century, not 3 times in less than 10 years. Outside the observatories, a different tension is building. Social media echoes with demands for raw, unfiltered data. Citizen scientists and science communicators are pressing for open archives, pointing to the sharp contrasts between backyard images and institutional releases. The most viral threads aren't accusatory. They're inquisitive. If technology has advanced so far, why does the clearest view so often come from a garage or a garden? Why do official channels sometimes go silent when the story turns strange? For every new visitor, the gap between what is seen and what is shared seems to widen. The call for transparency grows louder, not from a place of conspiracy, but from a simple desire to see the universe as it really is. The stakes are no longer just about one comet or one image. They are about trust, and about who gets to witness the cosmos as it unfolds. The sharpest mysteries in our skies right now aren't hidden. They are simply unspoken. As new visitors cross our solar system, public trust depends on clarity, not silence. The cosmos isn't waiting for official statements. Neither should we. What stands unexplained today shapes how we see tomorrow. Share your thoughts below, and don't forget to subscribe for more deep dives into the mysteries of our universe.